out in warfare. So the knife is a brilliant tool. It can be used in the hands of a surgeon to save a life. It can be used at the hands of a criminal to take a life. Does this mean that we should not be inventing useful tools?
In this episode, I'm talking with Professor Margarita Chli, who leads the Vision for Robotics Lab based in Cyprus at the University of Cyprus and the ETH in Zurich. Professor Chli is a pioneer in robot vision and autonomous systems, and her research focuses on boundaries of how machines perceive and understand and navigate the world. Margarita, I'm thrilled to have a chance to talk to you. I'm Susan Kish. I'll be hosting this conversation. And do I understand you're actually in Cyprus right now?
Indeed, I am in Cyprus. Very nice to talk to you, Susan, again.
So one of the things when you review your history is you focused a lot on vision, right? On seeing the world. Mm-hmm. Yet when I look at definitions of vision, there's lots of definitions of vision, and human vision and computer vision seem similar but not the same thing.
Indeed.
What is vision? Why is it so interesting for you?
As soon as I started working in the area, I was thinking that we do a lot of our scene understanding and our situational awareness, we call it in the field, largely based on vision. So in this sense, I was inspired. My work is very inspired by the capabilities that human vision has in perceiving the world. For example, let's say we are driving, right? Mm-hmm. And you see a tree, and the tree will not just stand up and walk across the street, but you see a cat. Fair. And you see, and you kind of already have a model about how that might move and come into your way, right? So with small things like this, I am using vision, and not just me, in general, in the field, in the community, we're trying to build up the capabilities of what robotic vision can do, sometimes having in mind what human vision can do, which is a very, very sophisticated tool. I'm not an expert in that, so I'm not a biology to tell you exactly how it works. And indeed, from what I have been reading, definitions vary. The photoreceptors that we have in our eyes and how we interpret the situation of the further deeper in our minds, how you translate all these ideas into things that you can do with pixels.
I can see that.
And that's why we do research. Yeah.
Vision is different for different animals and insects and snakes because of what they need, right? The faceted eye of a fly is different from the perception of a nocturnal animal, is different from the perception of a human, right?
Indeed.
And I think at that time, it just feels like, therefore, the vision that you design for a computer is fit for purpose. So in other words, that the problems you look to solve might be different for different kinds of computers. Is that a correct statement?
I think it's correct when you're thinking of the capabilities of the computer that you're having and the capabilities of the sensor that you're using. Because when we talk about vision, we talk about cameras, right? And we have different types of cameras, different capabilities. Cameras that work, for example, with visible light, like we perceive human vision to be doing. So we have cameras of different resolutions. We have computers of different strengths and capabilities, a battery lifetime that can be different. For example, when you're considering a small drone versus a bigger car, then yes, you can think of designing different algorithms depending on the units, the hardware you're going to run it on, the idea of what you want to do. For example, to provide a robot with the autonomy, it remains the same. Now, how you do that, if you have 1,000 pixels in your image, and if you have 2 pixels in your image at every a 30th of a second, then you might choose to do things differently.
So if I understand, your research looks at that intersection of robot and perceptions and autonomous systems.
Right? Indeed.
How does that work? Because if it's an autonomous system, a swarm, then theoretically vision is not only what one computer or machine sees, it could also be another computer looking at an angle from a different side. So it could actually be richer than how humans perceive.
Absolutely. Absolutely. I mean, as I said in my work, I say that I'm inspired by what human vision can do
Right.
in terms of capabilities, not necessarily in replicating the whole procedure of how human vision is doing it, but in many ways, computers or robotic vision at this stage can do better than what human vision can do. Now, on what you're saying and bringing in the swarm aspect, that's a whole different level. So imagine that you have one intelligent robot that is able to navigate the world. Now you had two robots that can look at the same scene from a different perspective. That means that you have access to more information at runtime while these robots are in motion, so during their mission. And if you have a good way of exchanging this information that is important between the two, then of course you can have more informed decisions on where to move next, on whether, is this an obstacle I should avoid? But in an ideal world, everything can be solved very easily. In reality, there are big questions, for example, on what information should I pass on to my coworker?
How do you exercise judgment?
Exactly. Because we don't live in an ideal world where bandwidth is infinite, where information is always useful and it's always reliable. So in general, to have a swarm of drones that is intelligently, navigating around and doing something useful, it's a very difficult problem.
Yeah.
If you work on computer vision, you have so many challenges to deal with when we're talking about variable lighting, wind. When you have multiple drones, one may come in the field of the other, right? And if you're thinking of them moving in the wild, you might have trees that are moving, clouds that are changing, people that are walking. So the computer vision experts, the researchers, are freezing some of these things. The communication experts, they want to work on how can I make sure that I have an interesting problem to address in the communications perspective. So if I am to talk about our perspective at the Vision for Robotics Lab, we use what is the latest communication protocols that we can use. Just to give you an idea, we just recently bought military grade communication devices such that our drones can communicate between each other in the best way possible, right? And then we are working on how can we address all the challenges that have to deal with all these weather conditions and the dynamicity of the scene. So we're dealing with all of that and trying to use whatever communication we can have in the same way that we're not working on the design of the drone. Because one can decide to optimize for that, as well. So we are at the stage where we can look through different layers of computer vision, going all the way from processing, at the smaller granularity of pixels and trying to build on top of that to have a semantically labeled scene. And you can say these pixels have to do with a face. These pixels have to do with a person. These pixels sometimes are figures. You can see it's whatever, my headphones, my chair. So when you have semantically labeled scenes, then you can start working out how things could be moving in the near future. This is a person. The person might move this way. This is a bookcase. This bookcase might not move much from one frame to the next. So once you have this built-in intelligence, then you can work with higher level path planning algorithms. How do I navigate from here, from A to B, taking into account that there is a cat there's a person on the pavement, there is a tree on the side, and I can see sunshine. All of these things that happen in our brain almost instinctively and without really explicitly thinking about them. They need to happen on the processing stack. That's why I'm saying that it's a big, big problem. And sometimes we have to freeze some of these variables like communication to be able to address the other problems. And when we're at the stage where computer vision is so advanced that we can deal with all of that, then of course, why not bringing into the equation also different communication? So talking to the communication experts. So what's the best thing that you guys have to give us? Talking to the hardware people. So what is the best thing that you guys have to give us? And then work on more optimized solutions on, for example, how your swarm of drones can navigate in a around your crops in a storm. No, you really captured one of the most impossible things to do right now, of course. So this is something we cannot do right now, not with the research type of drones that we're using.
How much of your work is, and this is probably an overly simplistic question, but how much of your work is on the hardware side and the software side?
So my personal background is on the software side. So when I did my PhD, and it was a PhD in robotic vision, it was my laptop and my camera and me.
This is at Imperial College in London.
Exactly.
Cool.
That was a few years ago. So I finished in 2010. And now as I progressed in my career, then robotics started to take off as well as a discipline, I would say, because we had more miniaturized computational power. The first drones that we got to use, they costed 20,000 euros in whatever, 10 years time each. There was one company that was doing them. And then later on, nowadays they cost almost, a fully equipped drone with stuff on there. It's like 5,000 or 6,000 euros. And you can order whatever, 5 or 6 of them to have in your swarm. So I don't work with hardware, so we try to work on the software. However, what I'm trying to say is that the more hardware you have to use, the more you need to work with it. So we buy our drones, but we need to customize them. But whenever we are thinking about, what is the problem we would like to address, right? What is the next big problem that it's close to my heart, for example. We would love to have drones that can help us in wildfires.
Yeah.
So in Europe, we've been having this problem in Europe, also in the US. California is on the news every year.
And they use them extensively, right?
Exactly.
During the LA fires, in terms of advanced notification, going places humans can't go.
Absolutely. And it's exactly places where you have real problems. You have smoke, you have things that are moving, you have wind. So how can you explain all that motion if your drone is only looking at things that are moving and you have smoke everywhere? So what sensor can you use there? So these are the kind of questions that we're thinking like, okay, maybe we need to go back to the basics. And maybe a heat camera is one that can help us out in such situations. But heat cameras have much lower resolution than visible light cameras. So now we have to work our algorithms with less information than our traditional algorithms that could, for example, monitor your field, your crops, for example. Right.
So I have to say, I have a son who is doing war studies at the King's College in London, and he's studying drones. Right?
Oh, nice.
And part of the reason is that it seems like every day you read new headlines about drone warfare in the Ukraine and how it's accelerating. The technology is accelerating so fast because of the real world life and death implications of that. How does that real world and your academic world, how do those intersect? Because it sounds like they're doing really, they had the first drone battalion, right? It just sounds fascinating.
Yeah, I mean, it is fascinating, it is scary, it is all of these things, right?
Yeah.
And it's true also for me. The first time I heard or I read of the word drone was in BBC articles about the war in Afghanistan, right? And indeed, every time I would go to give a talk, and I was talking about drones because we use drones as some of the most challenging robotic platforms to work with vision. And every time I would give a talk, I would feel the temperature in the room like really lowering. And I was like, oh, I can feel people are not really thinking that this is cool. It's not going to be a good conversation, a good, topic to discuss. And I kind of made it a little bit my mission, if you'd like, to also show people that robotics and drones have a lot to offer to humanities. It's not only about warfare, And I'm saying that, this is a big, military or not, is a big debate that I constantly have inside my head and out. The knife is a brilliant tool. It can be used in the hands of a surgeon to save a life. It can be used at the hands of a criminal to take a life. Does this mean that we should not be inventing useful tools? And so
that's a great analogy.
Yeah, and the same thing to me goes for drones and AI and research in robotics. But having said that, I definitely think that this is, what we're doing now, and the people who are listening, I think we all have a duty from our standpoint to pose these questions and pause and think about them and listen to each other's opinion, because I really think that it's the only way that we can shape where this is going. And what I think is worrying is that science is moving faster than our conversations and our legislation, right? So we need to make mistakes in order to figure out what not to do, where to put the limits where it's okay to navigate in, and we are not hindering progress, but we're not doing something that is harmful in general for people. So, I mean, I don't have the answers here, right?
That's exactly right. The history of technology is always accelerated in military situations, right? Because life and death changes the equation.
Absolutely.
And that was so true, 100 years ago in World War I, when you entered with swords and you exited with airplanes.
Yes, I have worked, for example, with the Swiss military on civil applications, on having a drone swarm help out in case of a radiation leak, for example. And since I was an adult, when the Fukushima disaster happened, I really thought that's exactly a very, very big challenge where we would need automation and robotics to help humans, right? To not have to push them, to put anyone in danger, and have robots do the dangerous bit.
That's right. So my bet is that although you did your PhD all those years ago, it sounds like you've been at the cutting edge of research as AI has matured, as machine learning has matured, neural networks, drone design. You probably could have put your laboratory anywhere. So why did you decide on the ETH? Because you were up in Edinburgh when you moved down to start the lab.
I think Zurich is the best place to do robotics research in Europe for sure. And definitely also ETH Zurich is very generous in providing people with the funds that are necessary to do cool research, and without too many strings attached, because that's also something that is not very easily probably seen if you're not on this side of the table, when you have your ideas, and maybe right now they're not cool, but in 10 years time they will become cool. So I think really ETH is providing this environment and this openness that could allow something like this to happen. So promising ideas to flourish, despite the fact that they might not look as cool at the moment. And I think that's the best thing one could wish for in a university.
Very, very cool. Margarita, this has been a fabulous conversation. And I feel like we're just getting started.
Oh, yes. Me too, to be honest.
And the questions you bring up and the research you're doing it's just really interesting. And it has impact, and having your clarity of vision, I think, so to speak, clarity of purpose and clarity of vision is really inspiring. So if it's okay, I'd love to ask you a few of the questions we always ask our guests.
Please.
Really starting off with when you were growing up, let's say you were 8 years old or 10 years old, what did you want to be when you grew up?
I probably wanted to be a ballet dancer. I don't know, a violin player. But I think, the role models that I had in my life, like my parents, they were math teachers at school. My dad, he was always hands-on to build things. My mom, very methodical with ideas. So I think I've been learning from both of them and their work ethic, and I've always wanted to, do something that's useful for people. And, it's all about, so that's where I think the passion comes from, to make a positive difference.
So then the corollary question, which is, what are you curious about today? What are you learning about?
I think everybody's curious about this. How is AI going to change our world, And many people think that, oh, you must know, you tell us. The truth is, I don't know. And I think because I don't know, I don't think anybody knows. And again, that's why I think it's important to make science communication clear. Or you might write the best paper in the world, but if you cannot explain it in simple terms, then nobody's going to read it. Nobody's going to use it. And the same thing goes for, this curiosity that you're saying. I mean, I don't think anybody knows where we're going. But that's why I think it's important to talk about it and keep the curiosity.
You struck a real chord with that. And if you're always curious, then the corollary is you don't think you always have the answers. And in a world that's changing, I think that's really important. I think thinking you have the answers feels like a slippery slope. But I have another question for you,
Please.
Which is, what books are you reading? What's on your bedside table or in your dining room or whatever? What are you reading or listening to?
Oh, it ranges from psychology to music to listening to podcasts about AI.
That is great. Thank you, Margarita. Thank you so much.
Thank you very much, Susan. Very nice talking to you.
I'm Susan Kish, host of the We Are ETH series, which tells the story of the alumni and friends of ETH Zurich, the Swiss Federal Institute of Technology. ETH regularly ranks amongst the top universities in the world for its research, for its science, and for its people. It's people who were there, people who are there, and the people who will be there. I'd like to close by thanking you for joining us today. Please subscribe to this podcast on whatever platform it is that you listen and give us a good rating. You can find us on Spotify, on YouTube, or on Apple. And thanks also to our production team, our producers at ETH Alumni and at LA Media. And especially to thank you, our listeners, for joining us today.